Hey there, Algebra 1. We're going to keep working on this Chapter 5, Linear Equations. We're going to work with parallel and perpendicular lines today, and it gives us an opportunity to review everything we've done in the chapter so far by adding on just a little bit of definition here. So we're going to talk about parallel lines. Notice we have a set of parallel lines in the word right there. All right, so just an old football field here. So you notice that the every 5 yards, those are going to be parallel. The other thing you could say is the sidelines are parallel to each other. Couple of different things that you have going on there. In perpendicular, we're looking for two lines that meet. Right, this is the symbol that we'll use. It's an upside down T, so that means it has and creates an intersection that creates a 90-degree angle. So they're kind of all over the place as we look at something like a power line, all these different places here. Okay, so we get some of those ideas. So if these lines end up being exactly the same, all right, that's what we're after today is the slopes of line 1 and line 2 must be the same thing. Perpendicular, we're going to come up with that definition here in just a minute, but let's take a look at some of these. So if you have a graphing calculator, you want to grab that. We're going to start by focusing in on one set at a time. So here's my y equals 3x plus 5 and y equals 3x minus 4. Now, we have an inkling right now that these should be parallel lines. Why is that? Because the slope is 3 for both of the same equations here. So slope of line 1 and slope of line 2 are both 3x. So let's take a look at it here. All right, now if you're using Desmos, you don't have to put in y equals. You can if you want to. It really won't care either way. But notice what we have as I zoom in and out is these look pretty much parallel. That's because they are, okay? So that makes up our first set from our equation. We notice that the equation we're both in slope-intercept form makes that a little bit easier. All right, let's take a look here. What's our next two? Let's take these off my board, and I'll come up with 4x plus y equals 4, and y equals negative 4x minus 9. All right, so let's see here. So that's our bottom two equations down here. Let's use a better color for that. So how did I get that? So for the top one, I really can't tell what the slope is just yet until I subtract this 4x over. And that's why that was part of your review. Negative 4x plus 4, and I have negative 4x minus 9. So these are again to be parallel lines, and that's exactly what we see here. Notice the equation just had to be rearranged. If you're using graphing calculator, you do have to rearrange it. All your equations have to be y equals. But notice in something like Desmos, these equations are just fine the way that they are. Right? It would just make a table for those. So we do have some parallel lines. All right, so that was the thing that we kind of felt is obvious. For parallel lines, remember, we're going to use a symbol like an 11. That means the slope of line 1 must be equal to the slope of line 2. Okay? Just for good measure, we want to make sure that the y-intercept is not the same as the other y-intercept. If that's the case, I don't have parallel lines, I have exactly the same line. So I do want the same slope with different y-intercepts. All right, let's take a look at the next set here. I got y equals negative 2x, and I have y equals positive 1/2 x. Now, they're definitely not going to be parallel, but let's see what's going on here. Let's turn those two off. Negative 2x, and then here's the, instead of doing 0.5, all right, instead of 1/2, look at that. All right, so, well, I'll be. Those sure look like they're making a perfect 90-degree angle. And for the sake of our definitions, that's exactly what we're after. Remember, perpendicular means upside down t. And how do I find that? So this negative 2 happened to be perpendicular to positive 1/2. So let me draw one more thing in here to hopefully make this pretty obvious. Did that do it? Okay, so I need to have the opposite sign, and I also have to have the reciprocal. Okay, so that means we want to make sure that we're going to flip-flop these as we do that. Okay, so the opposite reciprocal. All right, so that means change the sign and flip it over. Right, in common terms, that's what we mean. All right, so let's check the last set here. If I subtract 4x and I subtract 4x, I'll have y equals negative 4x plus 5. So if I'm studying negative 4, is it perpendicular? So that's the question. To 1/4. I'm going to put a 1 over that, put a plus sign on this one to make it obvious. And I'm pretty sure they are. So let's double check with the graph. And the idea is we want to get away from putting these graphs on here all the time. All right, let's zoom it out. Those look pretty good as well. It does look like they cross over at a nice 90-degree angle. Okay, so just want to use the graph to prove what perpendicular is and what it looks like. All right, so let's get a couple examples in here. So if I want to be perpendicular, let's say I gave you a slope of 2/3. Perpendicular to that is going to be negative 3/2. A slope of negative 1/7. Perpendicular to that, ooh, almost wrote an equal sign. They're not equal, right? Perpendicular is going to be positive 7/1 or just positive 7. Okay, so I just want to change the sign and I want to flip it over. All right, so that's what we're going to work with today while reviewing all of our linear equations as well. Okay, so here's what we have. Write the equation of the line that contains the point. So this has to be x and y and is parallel to y equals 3x plus 9. All right, so what's the slope of the line that we were given? Well, that's 3, m equals 3. Okay, so what's the slope of a line parallel to m equals 3? That's still going to be m equals 3. Use the slope and given point to find b. All right, so we're going to use point slope. So y plus 6 equals 3 is still the slope. X minus 2, let's distribute. 3x minus 6 equals y plus 6. And subtract the 6. So y equals 3x minus 12. All right, so are they definitely parallel? I would say so, because we had 3x and I still have 3x. And they have a different y-intercept. So that means they're going to be parallel. Okay, is it in slope-intercept form? Check. Done. Got it. All right, so here's how I can make this a little more difficult. Let's see, we want to graph the line through negative 2, 2, but it has to be parallel to this equation here. Well, here's the bottom line is it has to go through this point, right? So let's put that on here, negative 2, 2. Right, now what I have to do is I have to find out what the slope of this equation is. So I'm going to subtract 2x. So I get negative 3y equals negative 2x plus 6. This is as difficult as I can make this, guys. All right, now I don't really care about anything else except for this right here. So negative 2 over negative 3 becomes positive. So it's 2/3. What's parallel to 2/3? It's still 2/3, right? So that means in a slope of 2/3. So 1, 2, 1, 2, 3. And there we go. Okay, so it's kind of like using point slope to graph it because I know this point has to be on here. So I'm going to put this point on here right away. And then we solve to find the slope. And then we repeated that slope, right, up 2 over 3, and then we're in good shape. So you can see how I can change this question. I could change this word parallel to perpendicular. We do the same steps, except for we'd use a different slope. All right, the equation in slope-intercept form. Okay, so that's important. That's the end form I need to be in. That goes through the point. Okay, so this is my x and y. And I have to be parallel. Oh, nice. This one's already pretty much half set up for us, right? So that means I'm going to use m equals negative 3. So y plus 7 equals negative 3x minus 5. There it goes. Distribute negative 3x plus 15 equals y plus 7. Let's get rid of that 7 because slope-intercept form is when y is all by itself. Y equals negative 3x plus 8. Are they parallel? You betcha. How do you know? They both have a slope of negative 3. All right, looks like we got one more of those until we start talking about perpendicular. So let's get this one out of the way. And again, it says parallel. I already see that it's 6. So we're going to start off by putting it in point slope form y minus 2. All right, because it was plus 2, so I'm going to use minus. Slope is 6x plus 2. Let's distribute 6x plus 12. Y minus 2. Add that 2 out of there because we need y all by itself. All right, so 6x and 6x, they are definitely parallel, and they have different y-intercepts, so we're in good shape. All right, so you can see how we're gonna review a lot of that. All right, here is just pointing out exactly what we talked about. Perpendicular lines, they intersect to make a 90-degree angle. Okay, and how do we get that? We use negative reciprocals, all right? That's academic terms for change the sign and flip it. Flip it for real, okay? So 3, positive 3. So in this section, I'm intentionally gonna put plus signs on things that I never do. Positive 3 becomes negative 1/3, right? Because this was 3 over 1. All right, all vertical and horizontal lines are perpendicular, right? So if I give you an x equals 5 and a y equals -2, these are automatically perpendicular because I have one vertical line and one horizontal line. You're like, why'd you write that? Remember Hoy and Buck's vertical x equals, horizontal y equals, and it also has the slope in the middle there. All right, write the equation in slope-intercept form. That's the form we want to end up in, so that's important. It has to contain this point, and we want to be perpendicular to 3/4. Oh boy. All right, so first of all, 3/4 is positive, so that means I'm going to make it negative. And now since it's 3/4, I'm going to get 4/3. This is my new slope along with this x and y. So let's plug it in. Y minus 8, -4/3, x minus 1. Let's distribute. -4/3 x plus 4/3 equals y minus 8. All right, let's move this 8 over here. So y equals -4/3 x. Don't let this part mix you up. Remember, 4/3. 4/3 is actually 1 1/3. So we're going to change this straight up to 9 1/3 because I had to add 8 to that. All right, are they perpendicular? Yeah, that's by definition. That's what we did right here. Right, so we made sure that happened. Does it go through 1/8? Sure. Sure. All right, so here's that other one about graphing it. Graph the line through. I'm going to stop here. I don't care if it says parallel, perpendicular. I don't care if it says unicorns and amphibians. I don't care what it says. If it says 3, 1 is part of that line, 3, 1, it's going on my graph, right? Because if I don't hit that point, then I'm wrong. Perpendicular to a slope of -5. So -5 perpendicular. Right, so even though it's an integer, I'm going to make it into a fraction. So it becomes 1/5, and I'm going to put a plus sign on it, even though it's not necessary. So that means from this point, I'm going to go up 1, and I'm going to go over 5. It puts me at 8. And there you go. So I connect those 2 points, and then we're perpendicular to -5, right? So that means it should be positive 1/5, and it went through the point 3, 1. Yeah, that's why we did that right away. Right away, right away. All right, let's try this a couple more times. Hopefully you got it. If you want, you can pause it here, fast forward, check it in the end. If you're still not sure, then hang with me here. Perpendicular to 1/2. That's positive 1/2. So 1/2 positive perpendicular is going to be negative, definitely. 2/1. So I can just use -2. And here's my x and y. So y minus 6, -2, x minus 9. Distribute. -2x plus 18, you're equal to y minus 6. Plus 6 plus 6. You know the drill by now. Get y by itself. 24. It's a good thing I don't have to put that one on the graph. That's a tall graph. Start at 24 and then work our way down. Write the equation slope-intercept form. So same thing, perpendicular. So -5, I want to be perpendicular to that. So I'm going to, again, put it over 1. So it's 1/5, and it should be positive. So that's my new slope. Y plus 6, 1/5, x minus 1, distribute. 1/5 x minus 1/5 equals y plus 6. Get rid of that 6. Y likes to be by itself. All right, -6 and 1/5. All right, they're both negative, right? If you go to calculator, 1/5 is what, 0.2, something like that. So we can deal with it that way. All right, so we should be able to answer pretty much all these questions. And we'll throw some of these in there so that you know what in the world we'd be doing in class. That's if you have me for class. If not, yeah, I don't know what to tell you. Yeah, ask your teacher. All right, peace.